Hello, everyone. Should we wait for another minute? Let's wait for another minute just for other people to maybe running late. Yeah, welcome for the second day of Vox Days Thessaloniki. Our first talk will be about Java gems, Java hidden gems, tools and libraries. And we have on the stage Johan Janssen for the next 40 minutes. Please.
Thanks a lot for the introduction. So yeah, we are going to talk about Java hidden gems, tools and libraries, and it's a talk which covers a lot of tools and libraries, but only like brief introductions. So we won't go in depth in any of them. It's basically to give you a brief introduction so that maybe later when you need some functionality, you are aware that these tools exist. You can Google for them or simply look up another session on YouTube which covers them in more detail. So my name is, I work at ASML, I'm a software architect there, but my talk isn't really related to that at this point in time. And if you want to see the examples, actually I will cover some of them, but I can't cover all of them. I have 60 plus examples and it's a bit hard to show them in 40 minutes. So later if you want to have a look at them, you can go to my GitHub repository, this one, and click on Java Hidden Gems. And there you will find examples for all these projects. So really simple examples to give you an impression on what something does so that you can later dive into it if you want. So I split up the topics in a few different things like architecture, test, implementation, security, and builds. So we'll start with architecture. So let's simply look at some code. First one is ArcUnit. Basically what ArcUnit does is you can use it in your unit test to basically verify your architecture. And how does that look like? Let's start with the example at the top. And let's say we have different layers of applications, and we start with like a controller layer. And for that we have a package called controller, and we want to have all the controllers which have an annotation with REST controller, the Spring annotation, that the name of the class ends with controller. So then this is automatically verified. Next to that, we can also have rules about dependencies between classes. For example, my payment package classes can only depend on stuff in common or Java or Spring Framework classes. We don't want the payment packages to depend on things like the user or other packages to prevent things like circular dependencies and spaghetti code, basically. So this, you just run it as your normal unit test and then it's checked automatically every time. Same here for common. Common should only depend on stuff in common, not on stuff in payment or user or whatever package. And you can even do it a bit more advanced by using layered architecture, and you can specify layers. So I can specify a controller and a service layer. And I can say, okay, the controller layer is not accessible by any other layer because I have a JavaScript front end and not some Java code as front end. And the service layer is only accessible by the controller layer. So then if you run this and you have some issues, it basically shows nice exceptions like, okay, the controller layer may not be accessed by the service layer, etc. So this is really useful to continuously verify your architecture. And then we go to more implementation tools. First one is Awaitility. So if you have asynchronous code which you want to test, you can of course do something like sleep in it. Like here I do a thread sleep and then I see if stuff is there. Actually it's the one here. So I do a sleep in between to make sure that stuff is there before I assert it. But yeah, maybe on the server this goes quicker than on my laptop and I need to change those numbers sometimes. And it's also inefficient. I mean, if you have a lot of these tests, it takes a lot of extra time waiting basically. And that can be fixed by using the library called awaitility. And with that, we basically say await at most 2 seconds, but it basically checks if something is added to this list in this case. So instead of taking 2 seconds, it's done really quick. If we run this, we can see the difference between the two examples. So the one with sleep takes a bit more than 2 seconds, and the other one takes about 1 second. So if you have this for like 100 tests, it could save you 100 seconds for each build that you do. Then the next thing we're going to look at is the Jacoco agent. Who here is using Jacoco? Knows what Jacoco is. So most people probably know it from, know it from measuring coverage of your unit test or maybe your integration test, but you can actually do way cooler things with it as well. So let's have a look at that. So basically what we do is we start our application and we supply the Jacoco agent. And the Jacoco agent you can simply download from the Jacoco website. It's free and everything. We specify a target file and we say which classes should be instrumented. And what then happens is basically that whatever I do with my application, the coverage is recorded. So I can do a performance test, or I can do like a cucumber test, or I can simply click around in the application. And all that coverage is being measured. So let's see how that goes. So didn't I package it? So now we should be able to run it. Yes, so I have an application running. It's a really simple one, but I need a browser to access it. Oh. So it's just an endpoint that retrieves some information from a car, not really super interesting. Then what I do is make sure that you stop the application, and this is really important. The coverage result is only written after you stop the application. First time I tried this, I couldn't get it to work until when I went for a coffee and stopped the application, I realized that you need to stop it before the coverage is being written, so don't make the same mistake as I did. And now it writes the result in some binary file format, which is not really readable for humans. So we use the Jacoco CLI for download on the same website to generate an HTML report with this. And then we look at the target folder. It should be somewhere here, maybe even here. Oh, wrong one. Yeah. So now we see the coverage. So we looked at retrieving the results. So we accessed the get endpoint, but we didn't use the post endpoint, and we didn't access the exit endpoint. So this, you might be wondering, like, what can I use this for? One example where I did it in a project, we had quite good feature tests where we thought they would cover most of the functionality of the application. So we ran this Jacoco agent with the feature test, and then we found out that quite a large part of the code wasn't covered by the feature tests. And later, when we investigated, we found out it was actually that code, so we could remove that code. So there are some different applications for these kind of things. So it can be interesting to try out if you like to. Next thing is PyTest. PyTest is a form of mutation testing. So let's say we have this piece of code. I have a really simple test for it, so it definitely isn't a complete test for all the branches that you saw. And what basically mutation testing does is it runs the normal test, checks if the test runs successful, and then it changes the code. Not the test code, but the production code. So this is my production code, and what it does, for example, it changes this bigger than sign to a smaller than sign. It returns null or zero, for example. And for all those different changes, which it's called mutants, that's why they call it mutation testing, it runs the test again. And if the test passes, that basically means that your test isn't really good, because the code can be changed without your test failing. So this is a way to actually verify if you have all the proper asserts in place for all the branches that you have and all the different options in your application. And it's relatively easy to set up. It's just some configuration you need to add in your POM file. I configure which classes I want to instrument and which ones I want to exclude. And that's basically it. This is more or less something you could copy paste. And if we run this. So it takes, of course, a bit longer. For each test, it makes a few mutants. So it could be that if you have 100 tests, it will execute 800 tests. So probably you don't want to do this every build, but maybe once a night or once a week or something in that area. And then we have a report. So let's have a look. So at the bottom, we can see what changes it made. So for example, it returns empty or false, etc. So this is all the mutators that are active. Here you can see what it changed. So if we go a bit up. So on line 11 here, it made a change that it would return 0 and then run the test again. So now I can see, okay, all the green parts, there I have written proper tests, but all the red parts, I need to add tests or add asserts most of the time. So this is a really helpful way to test the quality of your tests. Often, like management says, you need to have 80% coverage. For me, that says nothing because you can gain it without having any asserts. And with this one, you can actually check for yourself if you made code changes, if you tested, improved the test as well in a good way. Then the next one is test containers. Anyone here using Docker or containers? I guess the rest was still sleeping. I think the entire world is using them nowadays, right? So basically what test containers allows you to do is to have an easy way to start up containers in your test and shutting them down at the end of your test. So for example, if you have a database and you need to run tests against it, in the past, we would install the database on our laptop, for example, the MySQL database, but then you also need it on the build server to be able to test the same or run the same tests there. And that's a bit annoying because, yeah, if you change the version or something, you need to change it in many places. With test containers, what we do is we just specify the container here. So for some things, there are default containers like MySQL, but you also have a generic one. So you can put in any Docker image that you have and run it. If you have Kafka or RabbitMQ or whatever service that you're using, you can just put it in test containers and run some tests against it. So in my case, I did some really simple stuff. I didn't want to use any other libraries, so I insert some books and see if I can get those books back. Really simple example. But yeah, you can do all the tests you did in the past with installed databases or other services you can do within these test container setup. And in the next example, I'm actually going to demo a few things at the same time to save some minutes, but actually you can use them all separately if you want. So what we're going to do is I have Gatling, which is a performance test framework, and let's run this one. And at the same time, what I will do is, let's first show the simulation. So Gatling is fairly simple. Maybe you've worked with something like JMeter in the past. I really didn't like it. It's a bit cumbersome. It has some quirks. If you don't use it the proper way, then your timeouts aren't as expected, and there are some other things that are a bit less nice. With Gatling, in the past, you had a Java DSL to basically specify whatever should happen, your simulation. Nowadays, they have a Java DSL, so it's even easier to use. Although the Scala one was also fairly simple. So what we see here is I specify the host that I want to use. I specify that I want to go to the car endpoint. I want to check the status. I want to do a pause. I go to another endpoint, and I again check the status. And that I do for 8 users. And those 8 users start over about 10 seconds. So at the beginning, I have 0 users. After about 5 seconds, I have 4 users. And after 10 seconds, I have 8 users. That's basically how it works. They have some different ways of specifying the amount of users. You can also have a fixed amount if you prefer to. So there's a lot of options in here. And what I'm going to start this one. And at the same time, we will also, I quickly need the command to do that. Maven Gatling test. And let's look at the same time at JDK mission control and flight recorder. So this is basically a way to profile your application in a really efficient way. This flight recorder is built into the JDK, so it is really high performance. Mission control you need to download separately nowadays. Before it was part of the JDK. So I can start a flight recording, specify whatever I want. There's a lot of details that you can enable or disable. Depending on what you enable, it can get a little bit slower. We start it, and then I quickly need to start my performance test as well. Okay, this is one of those times that the demo doesn't play nicely. What? Ah, thanks. Someone is awake. The wrong directory. Good one. And now probably I was too late for the mission control. No, it's still running. So it starts the simulation. It will also output some information on the console output so you can see the progress. So now it's started. It prints which things went okay and which things didn't went okay. So you see 4 active users now. Actually, some are already done because it's a really slow, short loop that I'm doing. So now this one is done, so I can look at the results of the Gatling tests for the performance. And this is actually one of the things I like about Gatling. You immediately get a report with all the information instead of having to do this yourself with, for example, JMeter. You need to use Excel or something to create these kind of things. This creates them automatically. So I see which requests went okay, what the response times were in the different percentiles, max response times, mean response times. I can see how many requests per second, etc. There's so much information. You even have a details tab with even more information that you can look at. So this gives a lot of information about your performance test. So if you need to do some performance tests, I can really recommend having a look at this one. It's quite easy to use, generates a report automatically, and yeah, you're good to go basically. And with mission control, basically it analyzed my application during runtime, and then you can get a lot of information for it. So it has some automated analysis. For example, it says, okay, the heap, most of the heap is used by only a few classes. Yeah, that's correct, because I have a really small application with, I think, only a few classes. But I can see a lot of other things as well, such as which methods are slow. So that way you can investigate, okay, this is my slowest method. Maybe I should spend time improving that one. I can see garbage collection summaries, also when a garbage collection took place, how much memory was used of the heap. So, for example, I know in the past when I got this out of memory and heap size errors, you simply double the heap and hope it's okay, right? But that might not be the best idea, because if you have a bigger heap, then once it's full, it takes longer to remove stuff. So maybe something in the middle would have been better. And with this application, you can easily see how your heap is growing, when which type of garbage collect is taking place, and that way have a more efficient way to specify your heap size. And then we go to some more implementation class libraries. And we'll start with equals verifier. Anyone here ever written their own equals method or hashcode methods? You think it was the right one? Yeah, I also tried, but failed miserably. So let's see how that went. So I have this student class, fairly simple. First name, last name. I wrote an equals method. Oh, of course, I need to compare the first names and the last names. And I thought, yeah, that should be quite okay, right? But then I use equals verifier. And the library simply, you can say, okay, test these classes if the equals method is okay. So let's do that. So if I run it for my first class, the student class, yeah, I assert that it gives a certain error message. So the test passes because I get that error message. And the error message is hashcode should be equal. So something is wrong with hashcode. So I looked up a bit more on the internet, tried to find a better example. And apparently I need to add final to the different attributes I have. My equals method should be a little bit more complex, like this one. And I need to add some hashcode. And if I do that, and verify it again, this time I simply use equals verifier and assert does not throw. Then I see that this implementation of my equals method and my hashcode methods is proper. So it's a good way to make sure that you write some reliable equals and hashcode methods. Then we have GraphQL. So with GraphQL, what you can basically do is it's a sort of SQL for your REST endpoints. So let's make this a bit bigger. So let's say we, in the past, and still now, you often have REST endpoints where you retrieve the information, and maybe you get like a megabyte of data back, but you only need to show the first name and the last name of a person. So it's a bit of a waste of downloading that 1 megabyte. You could fix that by adding yet another endpoint which only retrieves the first name and the last name, but then you might end up with like hundreds of endpoints for subtle changes of the information. The other way is to try and use GraphQL, which takes a bit more time to set up than just simple REST endpoints, but then you can basically query your endpoint. So for example, here what I do is I only retrieve the account, and then I can assert that I got the account information back, and I assert that I didn't get the user back. So an account has a user coupled to it. That's because I did this type of query. Then I can do another query where I say, okay, I want to have the same information, but I also want the first name and the last name of a user. And then here you can see, okay, I got that same information, plus I got the user information back. So this allows you to filter on your REST endpoint, which can be quite helpful. Then we go to handlebars. So maybe after today, you're like, yeah, I'm really done with this software development stuff. I want to do a new career change. Maybe you want to go into recruitment. Maybe some of you got some recruitment emails recently. This will help you to get started in it. So basically what we have is I should show the resource file as well. That makes it a bit more explainable. So we have like an HTML page. And in it, we have some special tags for example, the person, the first name, the last name, function title. We have some kind of loop structure. And then within Java code, we can actually fill that dynamically. So like this. So I have a job for someone who needs 20 years of GraalVM experience. PHP, of course, is also really useful. And of course, J2EE, because yeah, why not? And you need to have some really cool title, of course. Now, if I run this, I simply output it to the console, but you can also output it to a file or whatever you want. So this basically fills in every details that I wanted. So here now you also know why you always get these crappy emails from recruiters where they didn't fill in your first name or your last name or both. They basically have a template and forgot to do some details. So it's of course, it's a bit of a funny example, but you can imagine that if you need to send emails or something from within your application, you also need to put some dynamic content into it. And then this can also be really useful to use instead of copy-pasting strings and concatenating those strings or something like that. Then the next one is Java Poet. I think the name is already quite good. And with Java Poet, you can dynamically construct Java classes. So let's say I want to create this class. A student, again, with a first name and a last name, and I want to create it dynamically. So what I can do is I can use Java Poet to create a setter, a getter, a constructor, and then create the class and build that and check if the file that's created is like what I specified. And now you're probably like, why should I ever do this? Don't do this on Monday because your colleagues probably will hate you. So for a normal project, maybe this doesn't make a lot of sense. You just want to write normal Java code in normal class files. But if you create some kind of library and you need to dynamically generate Java code, then this is often used. So a lot of Java libraries under the hood use this one to dynamically generate Java classes. So if you ever have the need, have a look at it. Then we go to a project which is called TimeFold. In the past it was called OptaPlanner, but it became a separate company now. Let's see, I think I still have something running which I should stop. Or not. Let's see if it works then. Ah, it was running there. Oh, wait, let's first explain a little bit on how this one works. So a timefold is basically a way where you can schedule stuff. For example, if you have a business in delivery and you want to deliver goods as efficiently as possible, you can use timefold to basically get the best route, best distribution for your packages. But there are a lot of other problems that you can solve with it. I use it basically to solve the issue of conference planning, where you have multiple rooms, multiple speakers, and you somehow want to distribute them nicely. And for that, they specify rules, and the rules are basically used to get the best planning. So I put in some constraints. So for example, a room can only have one session at a time. It would be a bit weird if another speaker was standing next to me presenting a different topic, right? So it's simple Java code where you specify this. Then the next one is that a speaker can do only one session at a time. It's a bit difficult if I have to do 2 sessions at the same time, then I need to clone myself. And if a speaker has multiple sessions, he or she prefers to do them in the same room, because then the person is used to the setup, etc. If a speaker has multiple sessions, we want to punish him for that and make all the sessions back to back to give him a really tough job. Then we have language stability. So let's say here all sessions are in English, but let's say you would have sessions in Greek and in English. Maybe you prefer to do the Greek ones in one room and the English sessions in another room. Let's see how that looks like. So I have a lot of sessions here, all kinds of different topics. And this is basically the rooms I have and the time slots that I have. Now I can press solve and it will start searching for the best solution to put these in. And it's already fixed. So this is a really nice way. So we see English is in this room. We see Dutch sessions are in this room. So and in this room. So most of the rules are nicely followed. But I also see some issue here. Like, why are the 2 sessions in the same room? I mean, I made a constraint for it that it shouldn't do that, right? Anyone an idea why it still schedules 2 in the same room? It's basically a human error. I have more sessions than I have slots available. So you still have to do a bit of common sense to make sure that you don't destroy the rules that you have. And you can also see it a little bit at the top. So it says the score and basically 2 hard constraints. So for each rule you can define if it's a hard constraint or a soft constraint. You can see that it couldn't find an optimal solution. It had to do some sacrifices. And there is actually another sacrifice. For example, Sander Mak, you see he has a session here and he has multiple ones. So we specified if a speaker has multiple sessions, the session should be back to back. But here Sander Mak isn't speaking. And here he is again. That's also a bit weird. And while the first issue I actually deliberately included it, this one I made actually by mistake. And I also had to look up myself, like, hey, what went wrong? And I actually specified back-to-back sessions as sessions within like a 30-minute time period. And there is some kind of longer break in between. So that's why it's more than 30 minutes. So my constraint doesn't work. So you need to be careful with your constraints, that they are good. Then it will do the stuff automatically for you. And let's have a look at the next example, which is Job Runner. So with Job Runner, you can specify all kinds of jobs, for example, to make a database backup or things like that. And it also works with multiple servers in like a cloud environment. It makes sure things only happen once and that there is like a storage solution behind it to make that sure. So for example, this one, if this job fails, it will automatically be retried once. And of course it fails because I throw an exception, but it gives you an idea. For this one, I say, it's a recurring job. It should happen every minute. So then every minute these kind of things happen. And you get a dashboard and everything with it. So it's a really nice way to run all kinds of jobs if you need to do that. It's used by a lot of companies nowadays. And then we come to another tool which is called Spark. Oh, wait, it's under Apache Spark. So what Apache Spark does, it's basically a way to parallel process big amounts of data or heavy algorithms, to run it on multiple machines at the same time and distribute the work, and then later collect the results on the main machine, basically. So if you have big data processing or heavy algorithms, you can really consider this. What I also liked about this one is that it's really easy with this one to just process a big file. So I created an example. I downloaded a file from Amazon. Let's first start this run because it takes a bit of time. I downloaded an example from Amazon, a data set which contains all the reviews for a really huge amount of years. So it's a 29 gigabyte data set, and it will parse that data set and check for certain lines. Let's see the lines that it filters on. So it looks for things that contain the Java programming language as a reviewing text. So make sure next time you do a review on Amazon, include this text, then you will be included in the demo. So it processes this entire data set. I think it takes between 1 and 2 minutes, and it does it quite efficiently. I later tried to make the same example with just plain Java. Then I first need to Google, how do I read a file? Then when that finally works, I got an out-of-memory error because it's 29 gigabytes. It tries to keep in memory. With Spark, with just these few lines, it does that all automatically. Just make sure you don't run out of memory. It also works on a single machine. Of course, you don't get the benefit of parallel processing that way, but it's fairly efficient in reading files. Let's keep it running for a while. Like I mentioned, it takes about 1 or 2 minutes. In the meantime, let's look at some other things. For example, the OWASP dependency check, which is a security-related tool. So this one basically checks if any of your dependencies have known security vulnerabilities. So I can run that with Maven Verify. So let's do that. So now it goes over the list of my dependencies, and it looks on the internet for a huge file with all the vulnerabilities, and it tries to match them and see if there are any known issues. In my example, I run it on my laptop. Apparently, it still tries to do some stuff from the internet, maybe? No, this is the local host. So I run it locally to not have to download those big files. They're fairly big, and they regularly get updates, and I don't want to do that during a conference because it takes some time. Normally, of course, you want to have the latest updates because if new security vulnerabilities come out, you want to be notified of that. For whatever reason, it's really slow today. Yeah, let's say this is one of the times in demo it just fails. So basically it will say that I have a log4j dependency with a vulnerability. Maybe you've heard of some log4j issue in the past. It detects these kind of things. So it's a really easy way to test these kind of things. Then we have the POSI library. Whom of you wrote password verifiers by hand with regular expressions or something like that? No one? Everyone lucky here, apparently. So let's say we have some password that needs to be entered, and we need to process that. We can define some rules for it in a difficult way, or we can use this little library where we can specify the length, which type of characters it can use, and then I can simply run this against my password, and it will check. So, for example, if I use the password and I check if it's valid, it returns false. It actually returns 3 messages, and the messages are, don't remove stuff. Uppercase characters, digit, special characters. So then I do a more difficult one. It still complains because I have a numerical sequence, which I also didn't allow. So then I do some more difficult passwords, and those are valid. So this is a way to automatically verify them. Then we go to some more build-related tooling, where we'll start with JReleaser. Even further down. So with JReleaser, you can basically release your application in an easy way and have all kinds of help around it. So to publish stuff to Docker or to make release notes and things like that. So I don't publish anything in this example, but I can show you a bit on what it does. For example, I can do the the changelog is maybe the easiest one. So now it tries to create a changelog based on all the changes that I made. I don't know what's happening, but maybe my Spark is having a really hard time somehow. So it output the information in the target directory. And I have a changelog. So here it shows all the merges that I've done for code in this repository, basically. So it can do a lot of things on helping you release your project. If you want to know more information, Andros, the maintainer, and the creator is sitting there. So just ask him. He knows more about it than me. Then we have another tool, which is called Renovate. With Renovate, basically, what you can do is automatically get pull requests for your dependencies. So if I go to my own repository, no, not localhost, GitHub. So what it does is it checks all my dependencies and it checks if a new version is available on the internet, and then it creates a pull request. There are other tools that do the same, like the PandaBot and all kinds of tools. I just use Renovate as an example, but feel free to use any of the other ones. And then it simply creates a PR with the new version. You can even automate it, like at work we have this as well, and automatically after the PR is created, a build is run. If the build is green, then basically we can merge it because our test still passed. So that way you can make sure that your dependencies stay up to date over time without having to manually check, oh, is there a new version for this? Because basically almost no one does that. And then I see we're running slowly out of time. I'll show one last one, that's Open Rewrite. With Open Rewrite, you can basically run some kind of recipes against your application. And then it basically upgrades it. So for example, this one, let's run it really quickly, is used to upgrade several things. And in this case specifically JUnit 4 to JUnit 5, but you also have recipes to upgrade from one Java version to the other. And then it basically makes all the changes for you. And the nice thing is, it also makes language changes. For example, in the newer versions of Java, you have these multi-line strings instead of the nasty string stuff we had in the past. If it detects those in your code, it will also improve them. It will improve a lot of things and make use of new language features automatically, instead of you having to do that manually. And then basically you can do a git diff and it shows what's changed. So for example, this has been changed. It updated, of course, the dependency. Here I have some formatting, which is not really nice. It also fixed that. Instead of having a null, possible null here, it also reverses the order. So it does a lot of things to make sure you're up to date. So I can really recommend if you need to change something. It also has recipes to migrate from one framework to the other. So have a look at this one if you have any of those cases. It can save you a lot of time, and it does it locally. So if you don't like it, you just throw it away, right? And with that, we basically reached the end. So I would say thanks all for attending. And if you want to see more, look at my GitHub for more examples. Thank you all.